Okay, so I'm recording this for biology classes, for freshman biology classes, and this is what I call sort of the shell diagram workshop to get you guys adjusted and accustomed to how electrons, protons, and neutrons interact together within the atomic structure and where they are, how we arrange them. So as you can see up here, and I have files for these for you guys to use these in class. Element or molecule, right now we'll start off with just doing a couple of elements to pay attention to the location and how we place the subatomic particles. Here you can see proton, neutron, and electron up here. Here this dashed line represents where the atomic nucleus would be. Here, of course, indicating where the shell or the limits of the orbitals would be. And remember, we were talking about the number of electrons within the atomic shells. And for biology, the first shell will always contain a maximum of 2. The second shell will contain a maximum of 8. And the third shell, for our purposes in biology and for bonding purposes, the third shell will contain 8 as well. So 2, 8, 8. Now down here you can see I'm going to fill in the number of protons, the number of neutrons, and the number of electrons, and then the number of unpaired valence electrons. This indicating to us that we should have neutrality as far as the number of protons, the positive charges, the number of electrons, and the neutrons should always be equal unless otherwise stated. And what we care about are the number of unpaired valence electrons, remembering that the valence electrons are the outermost electrons, and the unpaired valence electrons are the single electrons that are available to bond with something else. So for our intents here, I'm going to shrink back down here so that I can write stuff in. But we're going to be working with, we're going to start easy, and we're going to do hydrogen. And hydrogen is very simple. The element hydrogen, simply because it has one proton. It's an odd font, but I'm sure you don't care too much about that. We're going to deal with hydrogen, and hydrogen has an atomic number of 1, which means there is one proton, and it also has an atomic mass of 1, which means it only has one proton, and it has no neutron. So one proton and one electron. And of course, the abbreviation for hydrogen, as we know, is simply going to be a capital H. So I'm going to grab the nucleus icon and pull it out over here. And I don't have to make a big nucleus here because I already know that the protons are found within the atomic nucleus. And in this case, there are no other subatomic particles in the atomic nucleus. It is solely one proton. That means for neutrality, there has to be one electron. And that means we only have to deal with one shell. So here I am dragging in and bringing up another shell, the first shell. And if we go down here, we should draw our attention to the ideas that, my apologies, that we can fill these in with the appropriate numbers. And so in this case, one proton, there are 0 neutrons, and I'm doing this in my home computer, so it's not as savvy as it is on the smartboard, and there should be 1 electron. And we're going to come back in and fill out the number of unpaired valence electrons in just a second. So going back up here, to finish hydrogen, if there's 1 proton and there's 1 electron, I'm going to put the electron up here. Its limit is by the shell, and here, this entire atom, we're going to call hydrogen. The difference here is simply that there's no neutron in the nucleus, and its charge is neutral because there's 1 negative charge and 1 positive charge. And we'll notice that the first shell, in this case, is the outermost shell. It's the valence shell. And there's 1 sole electron out here. It's not paired up with any other electrons. So when we come back down here, we can actually say, okay, we have 1 unpaired valence electron. And that means we understand that hydrogen is capable of making 1 chemical bond. So 1 chemical bond because of the one valence electron there. So I'm going to move on, and I'm going to do a slightly more complicated one. I'm going to do carbon, because carbon is definitely the organic molecule, the molecule for life. So we're going to do carbon, and hopefully as I'm doing this, you guys are going to check in your books, and you're going to find out what the atomic number of carbon is and what the mass number of carbon is. Because in doing so, that's going to tell us the number of protons, the number of neutrons, and the number of electrons. So hopefully you've already established that the mass number is going to, or sorry, the atomic number, it should be 6, which means there are going to be 6 protons. There should be, therefore, 6 neutrons, both, all of those within the atomic nucleus. And because we're dealing with electroneutrality, we should be dealing with 6 electrons as well. We're not really sure how many unpaired valence electrons there are yet, so we're going to go back up to the top and start filling them in and building our atom. So obviously I'm going to need the nucleus. And from the indications of what we know from the periodic table, there are going to be 6 protons and 6 neutrons here. So I'm going to make this slightly bigger so I can make enough room for everything. So there's 1 proton, 2, and it doesn't really matter how we put them in here as long as we understand that they have to hang out in the nucleus. There's 3, 4, 5. Sorry, again, not as savvy with it in my own house. All right, and then I've got 6 in there. That means I'll make this a little bit easier so you can see it. So that means I have to have 6 neutrons as well. So 1. Oh yeah, I got to put it in nucleus. 2, 3, 4. And I know that this seems tedious, but you need to be able to do this. 5. And 6. And the reason why you need to be able to do this is that you're going to understand why there are certain numbers of bonds that each of these can make. Great, so our atomic nucleus is set. We've got 6 protons and 6 neutrons, but now I need to bring in an electron shell. And obviously I'm going to have to expand the shell just so that for this diagram it can see there. But remember, this is still the first shell. So we place the first shell around the atomic nucleus. And we know that there has to be 6 electrons. Remember, how do we place in the electrons? There's 1 electron. And what's the maximum number we can have in the first shell? It should, hopefully you guys remember that the first shell, the maximum number is going to be 2 electrons. Okay? And then the second shell, there will be 8. And then in the third shell, there's a maximum of 8 as well. Okay? So for right now, we're dealing with this first shell, and I can place another electron in there. And we also understand that the maximum number of electrons that there can be are going to be 2. So this shell is now full. But we have to have 6 electrons for carbon, because if we scan back down here, we already know that there are 6 protons and 6 neutrons. I've got to fill in 6 electrons. So I need to get my second shell. I'm going to drag it up here. Of course, I say that and it's easier said than done. Drag it up here. Computer is being slow. Ooh, that's kind of funky. Okay, so, and now you can understand why I wrote the numbers there, because in the second shell we can have a maximum of 8 electrons. But how many more do we need to add? Carbon has 6. We've got 2 electrons here, so we can add 4 more. So I'm going to place an electron here. Can I add the next electron right next to it? I could, but there's all this other space all around here. So when we're filling this in, I want you to think of placing the first electron up top, place your next electron down at the bottom. So we've now got 1, so we've got 1, 2, 3, and 4 electrons. Now I could add it, the next electron here, but that electron's going to get repelled by that one, so it's going to move down here. It's going to get repelled by that one, and we're probably going to have to fill it out. Come here, boy. He's run away from me. We're going to place it here. And the same thing is going to be true when we add that last electron. It's going to bounce around and get repelled, and so they're going to occupy this shell spaced out like so. Notice that the first shell here has 2 electrons, but those electrons, as we've already indicated, there's a maximum of 2, and we've shown them to be paired together. Okay, so those electrons can't be involved in any chemical bonds. So we want to know the number of unpaired valence electrons. Remember the outermost shell, let me get rid of this 8. The outermost shell in this case is the second shell, and that's not the line that I was looking for, so that was sort of pointless. This is our valence shell, and I think that we can, whoa boy, and I think that we can all see that there are if I get the highlighter tool again, sorry guys, and in this case there are 1, 2, 3, 4 unpaired valence electrons in carbon. That means we got to come down here and write in 4. Keeping in mind, guys, that this also means that's how many chemical bonds carbon can be involved in. So carbon has 4 unpaired valence electrons and can consequently make 4 chemical bonds. 1 here, 2, 3, and 4. So there's lots of other atoms that we can do, and we'll do a couple in class. This is just to sort of remind you of what we did and how to do this. So review this a couple of times and then practice a few more on your own. We certainly want to make sure you guys can do the carbon, hydrogen, oxygen, and nitrogen at the very least. And then I'll do another tutorial later on actually making molecules.